Hello everyone, and welcome back to the Kontinuum garden project. This is our second video update, and we're thrilled to have you here with us. So first of all, a big thank you to all the supporters.
Yes, thank you so much.
And of course, a big thank you to everyone who commented, both here on Indiegogo, on Thingiverse, in the RepRap forums. We've gotten really a lot of feedback, and it's been great.
Yeah, I mean, the process has been really enjoyable and really productive.
In fact, we've been working really hard all week to have something ready to show to you today.
Yeah, we actually have the updated garden design, including struts and wheels and snap system and the base.
And so all the big parts and everything's been uploaded to Thingiverse.
Now, of course, this isn't the final design.
Because in a way, there is no final design. Because we've already shared these models online openly with everyone, so someone might take them and keep working, and there'll never be a final design anyway.
But it's no longer a representative model, it's the working printable design.
Absolutely, yeah. So these are STL files that you can feed into your 3D printer program, and theoretically, if your printer's big enough, print it.
Now, we've also been working on the drive mechanism.
Yes. So the drive mechanism also is not a final design because it totally depends on the speed of the motor that we put on the card. So for the working model now, we've calculated the gear ratio for a 2 rounds per minute motor. The motor turns the first gear at 2 rounds per minute. So the first gear has a circumference of roughly 65 millimeters, and it in turn drives a larger gear with a circumference of about 195 millimeters, which gives them a gear ratio of roughly 1:3. This second larger gear is connected directly to another gear like the first one with a 65 millimeter circumference, which in turn drives the main drive gear. Now this small gear meshes with the smaller section of the main drive gear, which has a circumference of about 266 millimeters. So that gives them a gear ratio of about 1:4. Taking into account, of course, that the drive gear has a 1:10 gear ratio with the large wheel of the garden, we arrive at the 1:120 gear ratio that we need. So going from a 2 rounds per minute motor, the gear ratio of 1:120 gives us the 1 hour rotation that the garden needs.
Now, we've also been working on the design for the growth boxes.
Actually, we've been doing more than just working on them. We printed some growth boxes.
This is the first one we printed.
We had the first design also.
It turned out not to work.
You print it like this, and you take the 2 parts and you snap them together, snap, and then this part bends so that you can put it in between the rails and it sticks. Doesn't work.
No.
But I have to say, one thing we did take away from this first print is that PLA, when printed right, is extremely flexible. So that's a very important lesson, and we're trying to use that to our advantage for the second design.
We actually have the second design right here, which is a completely different design. We printed like this with a cap, and then we use these lips for the snap system.
To put in between the rails. So you basically take the thing and you push it up between the rails, and these ones snap on there, and you can push them to take it out again.
However, we ended up, I mean, it printed with way too much plastic, so it's not as flexible as we want, which is why we printed another one.
Because to tell you the truth, this one is not flexible at all.
We printed one with a little bigger lip, less plastic in it, and yet it's still not quite flexible enough, so we'll be making one with even less plastic.
Even less plastic. This one has, in most of the walls, 4 layers of plastic, so 2 outers and 2 inner perimeters, with a little space in between even in a lot of places, and it's still just not quite flexible enough. But we're getting there. So I think the third version of this design will be close to our usable design of the garden.
Absolutely.
Yeah.
I think people want to see it snap in.
Absolutely, yeah. So this is the cap, you know, thing prints like this, but of course you use it this side up, so the plant sticks out of here. And it has this little thing to close off one side. Just snap it in like this, and there you go. Have a full box. I'm pretty proud of that. These boxes contain a volume of about 8 by 8 by 8 centimeters, whereas the first design was 10 by 10 by 10. It's just really not a problem as far as the size is concerned. We can make these bigger and smaller as long as the snap system fits in between the rails. We can expand the box downwards, make it wider, make it deeper, whatever you want. That's the beauty of 3D printing.
And it'll still fit into between the struts.
Of course, that only depends on this part here. So So I think it's a pretty flexible design, and,
Yeah.
and I think we can make something like this work.
Now that actually brings us to what kind of growth media we want to use.
Yeah.
We're talking about using rock wool. Rock wool, then you have a block of rock wool and you put your seedling in it, and then you put it in here. And you snap it in, and then it grows out of here. But we also want to try out coconut husk.
Absolutely, because it's again organic material. There's a slight problem as far as I see it, that we'd have to transport it from the other side of the planet. So that's something we're trying to not do.
Yeah,
and, rock wool is actually made right here next door.
Exactly.
So for us, I think the saner solution finally would be rock wool, but maybe it's not for you.
Yeah, but also we think that actually coconut husk can be reused.
Yes.
So that might actually be a factor we need to consider.
Yes.
The third thing we want to use is something called leca, which is baked clay balls.
Expanded clay.
Yeah, we're not quite sure how that actually works, but we're definitely going to try it out, and we might need to add something else to it.
Yes. Probably. It's mostly used. It can be used with soil-based gardening as well to give some air and water retaining capacities to the soil.
But more of that will come. We'll talk a lot more about that when we actually start growing plants.
Yes.
But for now, if you have an idea for something we might also try out, then please let us know. But until then, until we start planting,
we're going to start out, I guess, with the ones that we know work for hydroponic gardening. But we really like to do some actual experimenting. Maybe unbleached recycled paper and gravel works. Probably not. But you know what I mean.
I saw someone trying out plastic strips.
Yeah, printed plastic strips.
Yes.
So
it didn't seem to work, but maybe we can make it work. Who knows?
Yeah, I salute them.
Yes.
You have to try all this stuff. So, but we will of course be starting out with something that we know works, so that we can see if garden works.
Mm-hmm.
Now, as we mentioned, we've gotten really a lot of comments and feedback everywhere on Thingiverse and here on Indiegogo, and it's been great. And some of these comments, I think, deserve some replies. Basically.
Absolutely. One of them talked about why we didn't use a laser cutter.
Oh yeah, a laser cuttable design.
Yes. And we actually, I mean, we recognize that it might be a good idea. It just doesn't fulfill the needs that we've set up for this garden.
No, also it doesn't necessarily have the potential to reach the masses in the same way, because a laser cutter contains a laser, whereas a 3D printer only contains a heating element where the laser is, so it's much more low tech. The other thing is, on basic principle, the 3D printer is a more basic technology. It works straight with the raw materials, whereas the laser cutter needs a pre-processed plate that it can cut out. So in theory, actually you could make the raw materials for the laser cutter with the 3D printer.
And the 3D printer is more of a multi-tool. Once you have the 3D printer, you can make a lot more things for a longer time than you could with a laser cutter.
So admittedly, for the garden itself, it would definitely work. Absolutely work. And the production itself of the garden might be quicker. It's possible.
But it doesn't meet all the other needs that we're trying to fulfill with this project.
It would be a lot better maybe for some parts of the garden, but not so good for other parts. And the 3D printer can handle all of it. Mm. So we're going to stick with the 3D printer, but someone please make a 3D, like a laser cuttable design, and cut it and grow stuff. It would be great. So another comment we got was about nutritional needs. I think it was on the YouTube channel, and it's a very interesting question. It's very important. Obviously, this is all about food. So the question was basically, why didn't we base the whole design process on the nutritional needs of, say, a family of 4 or 2 people maybe?
Mm. Yeah, for example, why didn't we design the growth boxes to fit certain plants?
So the root system of certain plants that might need more or less space. As we already commented before, we have a design here that's very flexible as far as size is concerned. The beautiful thing is that as we publish the model, if you want to grow something with a huge root system, you make a bigger box. They're quite easy to change. So we are going to start out with the standard issue hydroponic growth box size and go from there. And this goes for the rest of the garden as well. Now the size of the wheels is basically predefined within certain parameters, because we need a certain distance between the central light source and the plants for them to have optimum usage of the light. Otherwise we waste a lot of light, or we can end up burning the leaves of the plants if they get too close. So so that's pretty much predefined. We've gone with a 1 meter diameter, and we're sticking with that. But again, if someone wants to experiment with the tiny little wheel or a 10 meter diameter one, go for it.
So as you can see, we've been busy.
Very busy.
We've been designing and printing the small pieces that can actually fit on a regular sized 3D printer, such as the growth boxes.
And in the near future, we will be printing a cutout of the snap mechanism. So basically one end of the rail and a section of the wheel, so that we can see if the snap mechanism we're proposing actually works.
Exactly.
But if we ever hope to be able to actually print these really large pieces, such as the wheels or the base itself, then we really need to build the big printer.
And we need to have enough plastic to actually print the garden itself.
Of course. And some materials for the light system, which is crucial. So some LEDs and wiring. So as you can see, it's a lot of stuff, and we really need your support. Also, keep in mind that we're not doing this for ourselves, or actually in a weird open source fashion. We're doing this for everyone, including ourselves. So that when the project is finished, of course, we will reap the benefits of having a fully functioning hydroponic system that's open source. But it being open source, so will everyone else. So anyone that wants to reap the fruits, so to speak, of this open source technology can do so. So if you want to, go for it.
So until the next update, thank you so much for supporting, and thank you for contributing.
And thank you for sharing.
Yes, please continue to share. That's the only way we can get this project out to as many people as possible.
Tell all your friends.
Exactly.
And then tell them again. So until the next update, take care.
Yeah. Bye.